In this question, we're going to focus on renewable energy, a little bit on density, and a little bit on efficiency of renewable energy. So the question starts with the wind turbines on a wind farm must have a minimum distance of 500 metres between them for maximum efficiency. Right, so figure 2 goes and shows this. Right, the fact that it's gone and told you that it needs that 500 metres implies that you are going to have to go and talk about that somewhere in your answer. Suggest one way in which the layout of this wind farm ensures maximum efficiency when the wind direction changes. Right, so this is where you'll simply have to go and state that the minimum distance, as shown on that diagram, is 500 metres, which means that it doesn't matter in what direction the wind's coming from, because they're spread out with that 500 metres minimum distance that they require for their maximum efficiency. So all you've done in that first part, which is why it's only worth 1 mark, is that you've just gone and used a little bit of information that's up there in the question. Right, the question then goes and moves on to the average mass of air passing through the blades of one wind turbine is 51,000 kilograms per second. Right, the density of air is 1.2 kilograms. So write down the equation that links density, mass and volume. Right, remember, all this is just a case of remembering your equations and just writing down the equation for density. So density is equal to mass divided by volume. Right, the second bit is where it gets slightly more tricky. So calculate the volume of air passing through the blades of one wind turbine every second. Give the unit, also give it 2 significant figures. Those 2 parts are important to remember later on. So we start off with the equation. So we know that density is equal to mass times volume. We know from the first part that our density is 1.2. We know that the mass is equal to 51,000. The first thing that you'll need to do is go and rearrange the equation. So we know, so we're trying to work out the volume. So density if we've got mass there, we are going to go and work it out as, so 1.2 is equal to our mass, which is 51,000, divided by volume. Right, we know that. So when we go and rearrange that, we'll come out with volume is equal to 51,000 divided by 1.2. So that then works out as volume is equal to 42,500. Right, remember, it's asking for it to 2 significant figures. So we're going to have to do something about that. So volume must be equal to 43,000. And remember, your volume is always given in meters cubed. So your final answer will be 43,000 meters cubed. The next part of the question you can kind of think about it in a very, very similar way to how you might go and calculate efficiency. So the average power output from wind turbine farm in figure 2 is 1.6 times by 10 to the power of 6. The average power output of a nuclear power station is 2.4 times by 10 to the power of 9. Calculate the number of wind turbines needed to generate an equal amount of power as a nuclear one. Right, this is one where it's easy to go and get things wrapped around your neck because you'll overcomplicate it for yourselves. However, all you need to remember to do is you're dividing the nuclear power output by the wind power output. So you'd go and have 2.4 times 10 to the power of 9 divided by 1.6 times by 10 to the power of 6, which will go and give you an answer of 1,500. The final part of the question states that the UK requires a minimum electrical power of 2.5 times by 10 to the power of 10 watts at any time. Give 2 reasons why wind turbines alone are unlikely to meet the use of this. Right, so it's almost just going and stating what you know about the problems of wind power. So wind power is not windy all the time. It's not windy in all locations. You need to construct a large amount of wind turbines to go and meet that requirement. Try and stay away, when it's talking about power requirements, try and stay away from things like it will harm the environment or it will damage the landscape and such forth, because that's not really what the question's asking. Right, go back, have a go at this question, take your time and try and squeeze out as many marks as possible, really focusing on the units that you're using and remembering those equations to help you gain those high grades in your exam.